All right, let's get started on animating our thug right here. And he is tiny, so let's just scale him up a little bit. Let's say 5, 5, 5. It's a bit too big. Maybe let's click this to link all the scales. Maybe 3 would be better. Nice. So we have the animation controller. And basically, what we want now is a way to smoothly blend between walking forward, walking sideways, running forward, all those animations. And for that, we use something called a blend tree. So most game engines have this. I know Unreal has something similar. So that's what we'll be doing now. So go to your thug, double click on the controller, go to the animator window. If you don't have this, go to Window, Animation, Animator. And let's right click here, create state from new blend tree. And we will call this the movement tree. And this needs to be driven by some values. So in here, go to parameters and let's rename this one to horizontal. And let's create a new float called vertical. So we have 2 floats, one called horizontal, one called vertical. Now in your movement tree, double click on the motion field here and change the blend type from 1D to 2D, freeform directional. Make sure horizontal and vertical are our 2 parameters here. Very nice. And let's set up the motion. So click the plus, add a new motion field. I guess the first motion we'll set up will be the walk forwards. So walk F. And so basically the Y will be our vertical. So +1 will be an input of W. So there we go. And then run will be +2. So pause Y here will be 1, and pause Y here will be 2. And now we need a run forward animation. So right here, drag that in. A idle animation. Drag that in here. Then we'll set up the backwards running or backwards walking. And this will have a Y of -1. And the run backwards will have a Y of -2. Cool, and just set this up, the strafing. So I'm pretty sure we only have 2 strafe animations, so let's just see what these do. So strafe 1 is strafing left. Strafe 2 is strafing right. So we will set this up. Strafe 1 is strafing left. Strafe 2 is strafing right. These strafe animations seem to be running strafe animations. Now, we don't have a walking strafe animation, so what we can do is copy the strafe animation, set the position X to -1. But here, see, this is the time value. So if we set this to 0.5, this will play this animation at 0.5 speed. And we can do the same for strafe 2. So play that one at 0.5 speed. So now we have a blend tree. So it'll blend between the different animations on the tree based on our horizontal and vertical parameters. So let's create a script so that we can visualize this, test it. So let's disable our room manager and let's add a new script to our thug called animation. Awesome. So this animation test script, So first, let's get a reference to our animator. We will add a private animator called animator, and we'll get a reference to this in start. So we'll do animator equals get components animator, and then we'll create two sliders for setting the horizontal and vertical. So we'll add a public float horizontal, and we'll add a public float vertical. And these will just be numbers in the inspector. So to make it a slider, add square brackets, write range, and the range will be from -2 to +2. And we will just do that for both of these. Next, we want to set the horizontal and vertical value of the animator to these sliders in update. So make sure you copy these parameters word for word, and in the update method, we'll do animator dot set float by the name of horizontal, and we'll set it equal to horizontal. We'll do the same for vertical. So animator dot set float vertical, vertical, and we can save this. In your game view, make this play unfocused so that we can view this while playing, and just click play. And if you go to your scene view, it is not working. Okay, we need to go to our animator. Let's right click on the movement tree and click set layer as default state. So it'll go from entry straight to our movement tree. And now this works as a charm. So we can walk forward, we can run backwards, we can walk backwards, we can walk forward, sorry, and we can stay idle. Now we want our player's hands to align with whichever gun we're holding. And for that, we'll be using something called inverse kinematics. Basically, it's a way of procedurally moving these hands to move them towards some target, aka the grips on our gun. Now to use inverse kinematics, we'll need to import a package. So go to Package Manager, go to Unity Registry, and search up Animation Rigging, and hit Install this. Now to make life easier, go to your thug, right click, go to Prefab, and click Unpack. And let's set up one gun here. So let's go to our player, Prefab, Unpack, and let's find our AK. Right here, Prefab, Unpack. Let's drag it inside of our thug, reset its position, move it up, position it nicely, scale it down. Let's disable the arms. Well, let's delete the arms in character. Let's disable the second mag, and just try to position the AK roughly where you would want it on the player. Very nice. Now, how do we make the arms align with the different grips on the AK? So I'll just rename the thug to player model. And on this player model, we'll add a component, rig builder, and this takes in a rig layer. So right click on the player model, create an empty game object, and we will call this rig layer. Move it to the top, and we'll add a rig component. Then we'll go to our player model and drag in our rig components. And under this rig layer component, create an empty game object, and we'll call this left hand rig. And in this left hand rig, we want to add a 2-bone IK constraint. And this will take in a target, hint, root, mid, tip. So for the root, we want our left shoulder. So go to hip, spine, chest, left shoulder. For the mid, it wants our left elbow. And for the tip, we will pass in our wrist. Nice. Now it also wants a target, so let's create a target for our left hand. Let's right click, create empty, and we'll call this L hand target. And let's give it an icon so it's easier to see. And let's just align it to our gun. Go to your left hand rig and drag in our target. Now let's play this to see if it's working. There we go. The hand is trying to align itself with the target. So just try to rotate it and position it such that the hand looks sort of reasonably aligned with the gun. And keep in mind that if you stop playing, all these changes will be reset. So I'll just move the gun a little bit. Now we will fix the fingers next, so don't worry about it. But just try to get the left hand, at least, sort of aligned with the gun. I'll just reposition the gun and make it a bit smaller, like so. And when you're happy with the position, copy the transform component and to paste this back on the target outside of play mode. I'll just keep sort of tweaking this and trying to improve it. And once you're happy with the position, and I think this looks quite good. So I'll just copy this once again, paste it outside of play mode. Now you may be wondering what the hint is. So basically, sometimes the elbow might go at weird angles. Here it looks fine, but sometimes the elbow might bend backwards or bend completely the wrong way. So to prevent that, what you do is you create a left hand hint. Let's make it yellow, for example. And you basically tell Unity in which direction you want the elbow to be bending. So we want it bending out and mostly down. So we place it here, and we drag that into the left hand hint right here. There we go. And we can obviously move this around a bit, however we want. Now let's fix our fingers. So let's make them sort of curl around the gun. You have to do this outside of play mode or else your changes won't be synced. But let's just curl each finger one by one. So just one joint at a time. There we go. Looks perfect. Let's play to see how it looks. And it seems like the animation might be affecting the hand position, which we don't want. So to prevent the animation from affecting our position of the fingers, we want to remove the fingers from our rig import. So go to your player model, go to the avatar, then go to your model, go to rig, click configure, and on each hand, you can just delete all of the bones. So just set all of these equal to none. And do the same for the right hand. And hit apply, and that should fix it. There we go. I'll just change the positioning a bit. That looks perfect. Almost perfect. Yeah, sweet. I'll copy this, paste it, and let's also set up the right hand, of course. So duplicate your left hand rig. Let's call this one right hand rig. And for the root, tip, and mid, obviously let's drag in our left hand shoulder, our right hand shoulder, our right hand elbow, and our right hand wrist. And we will duplicate our targets and name this one right hand target, and this one right hand hint. So the right hand hint will be out on this side, and our right hand targets will be somewhere around this handle. Let's very quickly make our fingers into a grip pose. So go to your right wrist and just bend all these fingers inside. Oh, oops. Fantastic. And now we can work on positioning our right hand grip. Our right hand target, sorry. Oops, we have to actually assign the targets to our right hand rig. So right hand targets and right hand hint, like so. Nice. And now let's move our grip. So just rotate it and put it inside of here. That is brilliant. This looks amazing. Look at that. All right, I'll copy the target position that we made, and I will paste this. And let's see how the animation looks. So hit play, and we're walking backwards. Walking sideways. Walking forwards. And walking backwards. Now we sort of want the gun to move with the player because it looks a bit strange for the gun to be completely still, right? And we also want the grips to move with the gun. Now, what do we want the gun to move with? Well, we want it to sort of move with the chest. So not each hand individually, but with the overall chest. So in our chest, let's right click, create empty, and we'll call this empty game object a TP for third person gun holder. Now let's drag our AK into the TP gun holder as our first gun. Now Unity is a bit strange in that if we remove these hints due to the movement of some parent game object, it won't actually register that these grips moved. So we basically have to move them manually in line with the movement of the gun. So let's duplicate these targets and drag them under our AK. So these will be the targets that move with our AK. And then we'll basically move these targets to align with the targets inside of the AK, if that makes sense. So I'll rename this left-hand target setter, and this will be right-hand target setter. And we will add a new component to this called target setter. And this will take in a transform target. And in the update method, we'll set target.position equals transform.position. Add this to both the target setters. Make the transform public transform targets. And for the left-hand target setter, and for the left-hand target setter, drag in your left-hand targets. For the right-hand target setter, drag in your right-hand targets. And if we play this, it works normally, but now the gun moves with our player. Isn't that awesome? This looks so cool. I can't wait to replace this. Now let's also set up our jump animation. So go to your animation test. Let's add a public bool, sorry. So go to your animation test. Let's add a public bool jump. And let's set up our jump in the animator. So let's find our jump animation. Pistol jump, drag it in. And we want to right click on any state, click make transition. So make transition to jump 0. And click on this arrow, move this all the way to the left here, and let's decrease the transition duration. And the condition for moving from any state to jump should be a trigger. So create a new parameter. So we'll create a trigger parameter, and we'll call it jump. Make sure this is a trigger and not a bool, so it's a trigger. So when the jump trigger, so the condition will be jump. So when this trigger is triggered, we'll move from any state to jump 0. Then right click on jump 0, click make transition, and we'll make the transition to the movement tree. So as you can see here, it'll play the entire jump animation, and then over this duration, it'll crossfade into our movement tree. And this will have no condition. The only condition is that it played the entire animation. Cool. Click on this arrow for any state and uncheck can transition to self. I think that should be all. Now we need to set the trigger in our script. So if jump, we'll set jump equal to false, and then we'll do animator.set trigger, and we'll set our jump trigger. Cool, let's test. So if you go to your player model, click jump, it plays the jump animation. Now it's really slow in my opinion, so let's try to speed it up. So click on your jump animation to speed it up, and let's set the speed to 2.5. That should work. Now, also very important, on your third-person AK, we want to remove all the animations and scripts on it, since we'll add separate scripts for third-person guns. So just go through all of these on your third-person AK and delete all of these scripts. Nice. Now let's move our player model to be inside of our player. So copy this, go to your player, and paste our player model, reset its position. Let's drag it inside of the scale fix, set the scale to 1, and we can now disable our bean. So go to the mesh renderer and disable it, and let's basically try to align our player model with where the bean was. So we actually need the bean, sorry. Just try to align the feet with where the feet of the bean are. There we go. And we can scale it up. Maybe 222 would be good. We can move the name tag up. Nice. And now we need some way of syncing the player's movement actions and then setting the animation to those actions. So now we need to sync the player's inputs for all instances of this player, and then use those inputs to set the horizontal, vertical, and jump on our player. So let's add a component to our player called animation syncer. This will take a public animator called animator, and it will have, similar to the animation test, a public float horizontal and public float vertical. Now these will be set by our movement script. So let's go to movement. In the movement script, we'll add a private animation syncer called animation syncer. We'll set animation syncer to be equal to get component animation syncer. And in our update method here, where we are guessing our input, we'll set animation syncer dot horizontal equal to input dot x, and animation syncer dot vertical equal to input dot y. Nice. Now we need to sync these values over the network. Now RPCs are quite expensive. Now RPCs take up a decent amount of network use, so it's not appropriate to use RPCs for something that we want to sync over and over very quickly. So instead, Photon has something called Photon serialized view to synchronize these values in real time. So at the top, add using Photon.pun, and over here, add a comma, and we'll add I.pun observable. And this is giving us an error because we are missing a function. So it's expecting us to add a function, and that function will be public void on Photon serialized view, Photon stream, comma, Photon message info, info. So create this function. And in here, we'll write if stream dot is writing, else. So stream dot is writing is called if this player is our local player and we own it. So if we own it, we will be writing. Otherwise, we will be reading from the network. So in writing, we'll write stream dot send next, and we'll send our horizontal input. And then we'll do stream dot send next, our vertical input. Now, if we're reading, we'll do stream dot receive next, right? And we want to write what we receive to some value. So we'll do horizontal equals stream dot receive next. And we want to cast this as a float. So first we receive the horizontal input. We're telling Unity this is a float. Don't worry, we know for sure it's a float. And we'll set our horizontal equal to what we receive. So let's copy this. So the next thing we receive is our vertical. So we'll set vertical equal to float stream.receive next. And now, similar to our animation test, we want to set our horizontal and vertical to these values. Cool, let's drag in our animator. So that'll be here. And on our player model, let's delete the animation test since we don't want to use it anymore. Now we will have one more issue, which is that we don't want the first person player to be visible from first person. And the reason is because it just looks very creepy. So what we'll do is we'll go to our player setup. We'll add public game object TP player, and we'll do TP player game object set active not photon view is mine, and drag in our player model into our TP player. Nice. Now let's also set up our jump animation. So our jump animation, we will actually synchronize via RPC, since jumping will happen less often. So we'll add a pun RPC, and we'll add a public void called RPC play jump, right? And in here, we'll do animator dot set trigger, and we'll set our jump. And then we'll code this RPC inside of our movement script. So inside of here, we'll do photon view. Oh, in here, add mono behavior pun, and add using photon dot pun. Then in here, we'll do photon view dot RPC. And the RPC that we want is RPC play jump. And we can do this because both the movement and the animation syncer both use the same photon view. So we can use the same photon view to call the RPC. RPC target dot all. So, RPC target the others, sorry. So we're sending this to everyone other than us. And that should do, since we have no parameters. Cool, let's build this and see if it's actually working. So save this and Control B to build this. Oh, my bad. Make sure to enable the room manager again. Delete the player we were working on, and let's just build this again. Cool, so both players have a player. Look at him jump. There we go. And now he's falling. So we're moving side to side. Oh, that's so cool. Look at that. Now, it's hard for me to show you, but we actually have proper players now. And there we go. Now, let's move the camera up a bit so it looks more normal, since our new player is a bit taller than was before. So move the camera to the head, so other players are head level as well. And let's change the collider size. So make sure that the collider is the full size of the player, like so. And now we are set. In the next video, we'll implement third-person weapon switching. So stay tuned for that.